Hello there, guys. .NET Study Room welcomes you to the WPF Chronicles series. In this video, we're going to understand the application class and various lifecycle events of a WPF application. The entry point of a WPF application is app class, which actually inherits the application class. Let's peek into this application class. To do this, press F12 key, or right-click and select Go to Definition. Visual Studio will navigate you to the file where this class is defined. You can see in title bar of this file, the class information is shown for metadata, and this file shown here do not contain actual code. At the top, there is the class constructor. If you expand the documentation comment, it reads, initializes a new instance of the application class. So obviously, constructor creates a new instance of application class. But also note that calling this constructor may throw an exception. The exception message says that more than one instance of application class is created per app domain. The type of exception is invalid operation exception. So what is app domain? App domain is operating system level thing. You can consider it as an enclosure which holds the whole application and all its required data. It creates boundaries among the multiple applications that are running simultaneously on the system. It basically provides isolation and security to the running application. Further, there are a bunch of properties defined. If you have seen the last video, you're already familiar with some of the properties. For example, notice the startup URI property. We use this property in App.xaml to set which window is shown when application runs. There is another property, which we will be using a lot, named current. This property is a static and get-only property. The value returned by this property is the instance of application class for that running instance of app domain. There can be one and only one instance of application class, and we refer to it by using current property. So you understand why we'll be using this property a lot. Furthermore, there are a bunch of events. We are going to see why and how to handle some of these events in a few moments. Lastly, there are a few methods. Many of the methods, whose name starts with on, correspond to handling some of the events. These methods are virtual, meaning we can override them, and we'll see that shortly. Any WPF application goes through a lifecycle, and it raises some specific events at certain stages of its lifecycle. Developers can take advantage of these events to identify the stage at which the application currently is, and do some tasks that best suits that stage of lifecycle. Sounds complicated? Let's simplify this. Let's start with the startup event, which indicates the earliest stage of application's lifecycle. The startup event is triggered when run method is called. Typically, the run method is called by the runtime. This event is represented by a method startup event handler. Let's now try to handle the startup event in code behind file of App.xaml. So let's write the name of event. Actually, we cannot directly write code into the class. Let's create the constructor of this class. Inside the constructor, write event name, startup, and use += to operator to attach a method to this event. Press Tab key to automatically create a handler method. Rename the method name if you want to, and press Enter key. Let's delete this exception throwing statement from newly generated method. The startup event handler method is ready. Whenever the application runs, it will raise startup event, and whatever you write in this method will be executed. There is yet another way to execute startup code, that is, by overriding the onStartup method. Type in override and hit spacebar. All the overridable methods are listed by IntelliSense. Select onStartup from the list and hit Enter key. Let's see how these two methods are executed and in which sequence by running the application. I will add a debug breakpoint at the opening brace of each of these methods to pause execution at the start of method. Now let's start the application in debug mode. And now see, the first breakpoint hit is the overridden method onStartup. And when base.onStartup is executed, it enters the attached event handler method. After executing both methods, the main window is shown on screen. What will happen if I comment out the base.onStartup call and run application again? Let's see. The execution completes the onStartup method call and then directly enters the constructor of main window. The window is then shown on screen. What have we learned from this? When application runs, the onStartup method is called. If you override the onStartup method, you can call base onStartup method, which causes all the attached event handler methods to the event startup to be executed. So, whatever actions you need to perform at startup, you can write in the onStartup method override, or you can attach an event handler method to the startup event and put your code there. The onStartup method takes one parameter of type startup event args. This class has a property named args, which is very useful. Basically, it is an array of strings, which holds all the command line arguments that may have been passed when application was run. Passing arguments to run an application is totally optional, so you need to check length of args, and if length is greater than 0, then you can access the arguments in startup code and take certain actions accordingly. Other than args property, there isn't anything much of use with this parameter. And now, typical use cases of handling startup event. Your application may need some settings to initialize and run. You can load application settings in startup. Further, your application may have multiple windows. You can use startup code, and then maybe based on command line arguments, or based on settings, decide which window to show. This is better done in startup event handler, because this event is triggered before showing any window. It is important to note that handling startup event is not at all mandatory. Next, let's understand two interesting events: activated and deactivated. Here's some code I've already written. I have attached event handlers for activated and deactivated methods. In the activated event handler, I have simply printed the name of handler method itself to the debug output. Likewise, the name of event handler method is written to debug output for deactivated method too. The debug output can be seen in this output tab when we run application in debug mode. Let's see this in action now. Let's run the application in debug mode and wait until main window is shown on screen. And there you go. As soon as main window is rendered on screen, observe in the Output tab, name of method, app_activated is printed in debug output. And now let me bring the Visual Studio window into focus by clicking on it. And see, app_deactivated is printed to debug output. When I switch to main window, activated event is triggered. If I minimize main window, deactivated event is triggered. To put in simple words, activated event triggers whenever the window gets focus. The deactivated event triggers whenever window is minimized or any other window is focused. As a developer, you may use deactivated event to maybe stop some background activities or stop updating UI when user is not using the window. Also, you may choose to stop accessing database, which is resource-intensive task when window is deactivated. And then you may use activated event to resume your stopped activities. This totally depends on your application's requirements though. Now let's learn three things which are related: the shutdown mode property, the shutdown method, and the exit event. I have now added an extra window to the project, named Other Window. There is no logic in its code behind. Let's instantiate an other window in main window's constructor and then show it. Now let's run the application. When application is run, main window as well as other window, both are shown on screen. I will now close other window first and then close main window. When both windows are closed, application shuts down. Now let's run application again. This time, I will close main window first and then close the other window. And again, the result is same. No matter in which order I close windows, the application shuts down only after last window is closed. This is evident by the value of the property shutdown mode. Let's assign the value of this property to a variable and add a breakpoint. This property is not present in the main window class, but an application class. So, we'll access it using application.current.shutdown_mode. Now let's run the application again and wait for breakpoint to hit. Notice the value of the variable shutdown mode. It is on last window close. Let's assign this property another value in app.xaml.cs file. This property can have one of three values defined in an enum named the same as property. OnLastWindowClose is the default value for this property. Another value could be OnMainWindowClose. Let's assign this value and run application again to see what happens. The expected behavior is, as soon as main window is closed, the application should shut down, causing other open windows to close automatically. No matter in which sequence I close windows, the application will shut down when main window is closed. Note that main window refers to the window which is set as value of property main window in the application class. Now let's try to set the third possible value, which is onExplicit shutdown. This value means the application will only shut down when we call the shutdown method which is present in the application class. Let's run the application now and close all the open windows one by one and see what happens. Both the windows are closed, but the application is still running. You can see that debugger is still running in Visual Studio. That's because application has not yet shut down. For now, we can just stop debugging, which will cause application process to be killed by Visual Studio. Now let's see how we can call shutdown method to shut down the application explicitly. We'll do this in window closing event. In the constructor of main window, add an event handler to handle closing event, and then replace the exception throwing statement with application.current.shutdown method call. Now this is similar to application shutdown happening when main window closes, but we are doing it explicitly. Let's quickly verify that same is happening. Run the application and wait for both windows to be shown on screen. And when both windows are visible, close the main window. The application will shut down. The shutdown method in the application class has one overload, which takes one integer as parameter. This integer value is the exit code of the process. The default exit code of any application is 0. Usually, exit code 0 means that the process exited normally. Other running processes may sometimes check the exit code of a process and determine if the process exited normally or with some error, and the exit code should be the code which represents exactly what error occurred. Finally, let's turn our attention to the last, but not the least, event of application class, exit. The exit event is triggered after the shutdown method is executed. That means exit event indicates that application is now exiting, and now it's your last chance to execute any logic from this application's code. You can utilize this event handler to release any resources that application may have acquired and avoid deadlocks on those resources. Another simple reason to handle exit event is to write a log for application exit time if your app uses logging, which is a good practice to follow. Further, you can perform some application-specific cleanup tasks. And also, you can persist the state of application to a file and use that file on next startup to continue the application from where it was exited. Notice the second parameter to this handler, exit event args. This type has a property, application exit code. You can set this property value, which will override the value of exit code set by shutdown method. And this exit code will be reported to the OS finally. So this is the last chance of setting application exit code. Once everything in the exit event handler is executed, the application has completed its complete life cycle. That's it for this video, guys. I'll see you in the next one. Remember, learning is all about practicing. So start practicing all the concepts you learned today. And do not forget to subscribe to the .NET Study Room channel if you haven't already. Bye.